Okay guys, once again we are using the Technology in Action 5th edition book. If anything is ever unclear at the end of these presentations, please go out and purchase this book. Chapter 6, we're going to understand and assess our hardware needs. We're going to evaluate our system. The main thing that we're going to cover here is whether it's time to buy or upgrade our system. We're going to do that by evaluating our system. We're going to look at our CPU, our RAM, the storage capabilities of the computer, the video output displays, the sound system, and the computer's ports. We're also going to see how to deal with system reliability. The first thing you want to take into consideration is whether you want to buy or upgrade your system. Things to consider with this is Moore's Law. Moore's Law loosely states that every 18 months a computer's transistors double themselves. The cost of upgrading versus buying. The time it will take you to install the software and files if you do buy a new computer. And then you really got to measure your needs versus your wants. If you're sitting with a Pentium 2 dual-core processor, do you really need to update to a quad-core processor? As opposed to, if you're still back on an Intel Pentium 3 processor, it's probably time to upgrade your system. We do this by assessing our hardware and evaluating our system. We're going to assess the system's subsystems. The subsystems include the CPU, the central processing unit, your RAM, your random access memory, your storage devices, such as your hard drive and CD and DVD drives, your video ports, such as your actual physical video card and your monitor, your audio cards and your actual speaker system, and the additional ports on your computer. You also want to consider upgrading to a desktop or a notebook. Desktops are hard to move around, but they're generally cheaper than a notebook. They're usually difficult to steal, but they're also a lot easier to upgrade. If there's ever a problem with your desktop and you're not able to take it to the store, they become difficult to ship for repairs. A notebook is great for portability, but they're generally a lot more expensive. They're easily stolen, and they're very difficult to upgrade. They're also prone to damage. When looking at your CPU, your central processing unit, there's three main things that you need to understand about it. The two main functions of the CPU are its control unit and its arithmetic logic unit, or the ALU. The control unit basically handles all the basic operations of the computer and all the peripheral devices. The arithmetic logic unit handles all the calculations of the zeros and the ones inside of your computer. So this handles the statements like and, if, or statements, equal to, greater than, less than statements, things to that nature. The other thing you want to consider is your machine cycle. This is these things that are considered your clock speed. So if your machine has a 1.8 gigahertz processor, that is the speed and the cycle that your computer operates at. What a machine cycle is it fetches information from the RAM, and then it decodes that information into something that the processor can understand. Then the processor executes that code and command, and then the information is stored back on the random access memory. Every time this cycle goes through, it is called a machine cycle or a clock tick. These are measured in megahertz and gigahertz. Most computers today are clocked in gigahertz. When looking at the CPU, you want to evaluate some of the other features, such as your front side bus and your cache memory. The front side bus is the way information travels between the system's memory and the central processing unit. The faster the front side bus is, the faster your computer will operate. The cache memory is actually memory either attached to or very, very close to the central processing unit that is dedicated specifically for the CPU functions. Some CPUs are optimized to process multimedia instructions. Intel has developed CPUs called dual-core and quad-core processors. These use less power than dual processing. They also increase multitasking performance. Let me explain some things here when you're evaluating your CPU. For the longest time, you were able to tell how good a computer was and how fast its CPU was based on its clock speed. Now remember, the clock speed is how fast the computer can handle its operations. So a 1 gigahertz processor would be much slower than a 2.0 gigahertz processor. Likewise, a 2.0 gigahertz processor is much slower than a 3.0 gigahertz processor. For a long time, you were just able to look at that number and determine how fast and how well your CPU would operate. Then came along the concept of parallel processing. This basically was, on a motherboard, you'd be able to attach two separate processors. So if you had two 2 gigahertz processors, you would have basically the combined computing ability of 4 gigahertz. Now don't let this confuse you with what a dual-core processor is. A dual-core processor basically was birthed from the parallel processing concept. But this is very important when going out to buy a computer. If you go out and buy a 2.0 gigahertz processor in a dual-core system, you do not have a 4.0 gigahertz processor. You have a 2.0 gigahertz processor that each section of the core works on specific functions. It divides the processing power in half. So a quad core would, on a 2.0 gigahertz processing system, is not an 8.0 gigahertz system. It is still a 2.0 gigahertz system. It just allows you to be able to multitask much easier, and it allows the cores to handle their own specific tasks. For example, if you have Microsoft Internet Explorer open, and Microsoft Word and Microsoft Outlook open, if you were to try to run all those programs on a single core processor, the computer is going to be bogged down and run much slower. As opposed to on a quad core processor, each section of the processor can handle a specific delegated task, which that makes the computer run much more efficiently, not necessarily faster. The only way to double processing power is to do what is known as parallel processing, which again is when your motherboard accepts the capabilities of having two separate processors in it. When upgrading a CPU, understand that this is very expensive to do. It's relatively easy to install these CPUs, and you have to make sure that your motherboard is compatible with the CPU. If you're dealing with an older Pentium 3 based computer and you try putting in a quad-core processor, it's probably not going to work. Motherboards are generally specifically designed to work with a specific processor, so make sure you check and read up on what you're doing before you do it. When looking at the RAM in your computer, which again, your RAM is your random access memory. This is the short-term memory of your computer. It is temporary, volatile storage. That's what VOLTIL means. It means temporary storage. Understand that your memory modules may not fit on the specific motherboard you're using. Most of them do, but you want to check your compatibility. Most memory modules today are DIMM-based, which is dual inline memory module based memory chips. Also, there's different types of RAM, such as DDR, DDR2, SRAM, SDRAM, and DRAM. So you want to check your specifications of the RAM before you put it in and make sure it is compatible with your motherboard.